This call is now being recorded.
Boleh dengar suara saya tak?
Boleh, sir. Boleh, sir.
Alright. So, still waiting for another 30 person. Okay, we will start in 3 minutes. Okay, so far soalan tutorial ada masalah tak? Tutorial question. Ada tak yang awak tak berapa clear lagi? Tutorial question yang until question number 10 tu. Ke semua okay?
Sir,
Okay saya.
yang nombor 7 kan? Nombor 7. Yang apa? Table yang bawah sekali kan dia bagi number of oxygen atoms kan?
Okay,
Lepas tu kalau kita nak, maksudnya kita kena reverse lah kan untuk cari number of molecules, number of moles, betul kan?
Ya betul.
So macam nak cari number of molecules tu, sir?
Selalunya kalau soalan calculation, okay, so for chemistry, normally kalau awak confused, awak cari number of mole dulu. Awak refer ke number of mole dulu. So from the number of mole, awak boleh cari yang lain. Cari dulu number of mole daripada number of oxygen atoms yang dia kasih tu, convert to become number of mole, then from there you can find the number of molecule and also the mass of the compound. Dia macam tu. Apa-apa cari mole dulu.
Okay, so number of oxygen atom tu kita kena guna dengan Avogadro number lah kan untuk dapatkan
number of mole. Yes, betul.
Alright.
Okay.
Thank you, sir.
Welcome. Okay, baru 57. Kita start sekarang. Okay, so Assalamualaikum and a very good evening. Okay, so hari ini we're going to cover quite a lot of subtopic. So mole concept, which is include the number of particles, the molar mass, molar volume. Okay, this subtopic kita akan recall balik je lah dengan apa yang awak dah belajar dulu. So and then we can continue with the molarity, mole fraction, okay, and then percentage by mass and also the percentage by volume. Okay, screen yang saya share ni boleh nampak?
Boleh,
Screen boleh Alright. So by the end of this lesson, okay, you should be able to define mole, okay, in terms of Avogadro's number and also carbon to atom. You should be able to calculate the number of particles, molecule, atom of iron lah, okay, and molar mass and molar volume, and define and calculate each of the following concentration measurement. So we have molarity, mole fraction, percentage by mass, and also the percentage by volume. So yang the first two learning outcomes ni kita buat ringkas je. Okay, awak pun dah tahu. Okay, and the third one yang kita akan fokus hari ni. Macam mana nak kira different expression for concentration. And also we're going to learn about dilution hari ni. Kita akan cover pasal dilution dah. Okay, so we're going to start with the mole concept. Okay, macam yang mole concept ni, awak boleh assume dia macam, okay, contohnya lah. Kalau saya ada a dozen of egg. Okay. So kalau kita dengar perkataan dozen, maknanya ada berapa bilangan dia?
12.
12. So kalau saya cakap saya ada a pair of socks, maknanya kita ada dua. So awak boleh assume mole ni sebenarnya ada sama je. It's still the same thing just like dozen and a pair. Mole is a counting unit. Okay, mole is a counting unit. However, mole is a counting unit for any type of matter. Okay, the reason why we going to use mole, okay, sebab macam yang awak pernah tahu pasal Avogadro's number. Okay, dalam Avogadro number, so for example, 1 mole of any substance, okay, the number of particle inside it is 6.02 times 10 to the power of 23. Awak tengok bilangan dia adalah multiply 10 to the power of 23. So maknanya kalau awak nak sebut number tu dalam our in daily life, dia besar lah. So that's why kita ringkaskan dia, kita menggunakan mole. Mole ni is we call it as a counting unit ataupun kita panggil dia sebagai amount of substance. So kalau dalam chemistry, kalau dia cakap pasal amount of substance, kita akan gunakan mole. Okay, so awak kena betul-betul understand the concept of mole because mole concept is very important especially for calculation. So everything is depend on mole. Okay, another thing I want to emphasize is pasal ratio. Because mole concept is also about the ratio between the chemical that involved in the chemical reaction. So awak kena mahirkan pasal ratio dan awak kena mahirkan pasal mole lah. Okay, so macam saya cakap tadi, mole is basically defined as the amount of substance that contain the same number of particle in 12 gram of carbon 12. Okay, and then after they done the experiment, they found out that the 12 gram of carbon 12 contains 6.2 times 10 to the power of 23 particle. Okay, this one yang kita panggil dia sebagai Avogadro's number. Or normally for Avogadro number, kita akan tulis dia sebagai macam ni je. Capital N and subscript capital A. Na. Dia bukan sodium. Kalau sodium N besar kecil, tu beza dia. Okay. So kalau the short form for Avogadro's is Na lah. So 1 mole of any substance, tak kisahlah the molecule, the ion, the atoms, 1 mole of any substance, the number of the particle must equals to the Avogadro's number. Okay. And 1 mole is also equivalent to 12 gram of carbon 12. So let's say, kalau saya ada, so we know that the 12 gram of carbon 12 is equivalent to 1 mole of carbon 12. Okay, awak familiar tak dengan yang simbol ni? Yang 3 garis ni, familiar kan?
Familiar sir.
Okay, so okay lah. So itu maknanya adalah equivalence ataupun ratio ataupun proportion lah. So we know that 1 mole of any substance, okay, 1 mole of any substance is equals to, so 1 mole of carbon 12 is equivalent to Avogadro number. So particle. Okay, let's say kalau saya doublekan number of mole of carbon 12 ni, berapa number of particle dia sekarang ni? Kita kena buat apa?
Darab.
Darab dengan berapa?
Darab 2.
Okay, darab 2 kan sebab dia dah berganda 2 kan? So that's why saya cakap tadi, awak kena mahirkan mole and also awak kena mahirkan pasal ratio. Sebab kalau awak mahir ratio, calculation dekat dalam chemistry ni dah senang dah. Dah senang dah. Okay, so kita tengok contoh ni. Okay, ini pun ada pesawat, so saya hanya akan tunjuk few example lah. So let's say if we have 1 mole of HCl. Okay, how many HCl molecule? Okay, if the question asks you number of molecule, number of atoms, number of ions, okay, number of compound, okay, you need to multiply or multiply by Avogadro. So 1 mole, we have 1 mole of HCl. So the number of HCl molecule dia berapa? Number of HCl molecule dia.
6.02 kali 10 kuasa 23.
So basically equals to the Avogadro number. So 1 mole of HCl is equals to 6.02 times 10 to the power of 23. Okay, so what is the unit? Dia ada unit, tapi unit dia apa?
Molecules.
Molecules. To be specific, HCl molecules. So for this kind of question, the unit is depend on the question. So if question asks you number of atoms, then the unit is going to be number of atom. If the question asks you the number of ion, then the unit is going to be number of ion. Okay, so number of hydrogen atoms in 1 mole of HCl. So we can use ratio. So 1 mole HCl, okay, is equivalent to how many mole of hydrogen atoms? Ada berapa hydrogen atoms dalam HCl tu? Ada berapa?
1.
1.
So there must be 1 mole of hydrogen atom. We know that 1 mole of anything, substance, atom semua must equals to the Avogadro number, and unit is hydrogen atoms. Okay, same goes with Cl atom. We still can use the ratio. So 1 mole HCl is equivalent to 1 mole of chlorine atom. Reason dia sebab kenapa chlorine 1 mole is because if you look at the chemical formula, we only have 1 chlorine inside HCl. That's why we call it as 1 mole. Okay, so the number equals to Avogadro number of chlorine atom. So kalau saya tukar 1 mole ni kepada 0.5 mole of HCl, okay, what happened to this number? Kalau saya halfkan mole ni, what happened to this number? The number of atoms semua ni apa?
Kurang juga.
Dia akan berkurang kan? So dia akan berkurang sebanyak half. So let's say 0.5 mole HCl, this one you need to divide it by 2, this one you need to divide it by 2, and also this one you need to divide it by 2. Or you can also multiply by 0.5 lah, it's still the same. Okay, so far okay. Ada apa-apa soalan setakat ini?
Tak ada sir.
Okay, so kalau saya laju, tolong cakap kalau saya laju. Okay, so 2 mole of chlorine, Cl2. Okay, so number of chlorine molecule. Okay, ada berapa chlorine molecule dalam ni?
2.
2.
Satu.
Okay, Amira Akram, kenapa awak jawab 1?
Sebab dia kira molekul, kalau atom kira 2.
Yes, right. Molecule Molekul maknanya dia dah ada chemical bond. So molekul dikira satu. That's why waktu mula-mula kelas dulu, saya suruh awak baca yang dalam nota sebagi tu, page 195 tu dia terangkan what's the difference between element, atoms, molecule semua. So awak kena betul-betul fahamkan basic konsep tu. So we have one chloromolecule. Kalau awak cakap dia ada dua chlorine molecule, dia akan tulis macam ni. 2Cl2. 2Cl2 ni baru ada dua chlorine molecule. Okay. So 2 mole of chlorine atom, okay, determine the number of chlorine molecule. Okay. So we know that 1 mole of chlorine is equivalent to 1 mole of chlorine molecule. Okay, so sekarang kita ada dua, so kita kena buat apa?
Darab 2.
Darab 2 je lah. So, Avogadro number multiply by 2. And the unit is going to be chlorine molecule. Okay, tapi dalam exam awak jangan tulis Na ni Awak tulislah dia punya exact value dia. Okay. So, number of chlorine atoms. How many chlorine atoms in 2 mole of chlorine molecule? Ada berapa chlorine atoms?
2.
2. Okay, kita tengok 1 mole chlorine molecule, ada berapa chlorine atom dalam 1 mole? Ada berapa chlorine atom? Dekat sebelahnya ada nombor 2 kan? Maknanya kita ada 2 mole chlorine atoms. So now we have 2 mole of chlorine molecule. Then we're going to have 4 mole of chlorine atoms. Sebab awak tengok dia punya ratio je 2 kali ganda. So kalau if you have 1 mole, number of chlorine atom is equal to 2. So dia double. So kalau awak dapat 2, number of atom dia adalah 4 mole. So basically awak punya exact number of chlorine atom tu, so 4 multiply by Avogadro number. Okay, boleh tak ni?
Boleh sir. Boleh sir.
Boleh Yang lain okay, yang lain. Okay. So, kita tengok yang okay kita tengok yang compound pula. So, I have 1 mole of aluminium oxide. Okay, so sekejap saya panggil nama terus lah. Brenda.
Yes, sir.
Okay, so if you look at the question, okay, what is the number of aluminium oxide compound in 1 mole of Al2O3? Okay, ada berapa aluminium oxide compound dalam tu? 1 mole kan? Dia ada 1 mole. So, 1 mole of anything is equals to bersama dengan berapa? One mole of any substance. Dia bersama dengan apa?
6.02 kali 10 kuasa 23.
Okay, so correct. So, okay, thank you. Okay, aluminium oxide compound. Okay. So, the number of aluminium ion. Okay. 1 mole of aluminium oxide is equivalent to how many mole of aluminium ion? Ada berapa mole ion dalam tu? Kalau awak tengok ni.
6 je.
Aluminium ion. Bukan 6. Aluminium bukan 6.
1.
Ada nombor berapa? 2 kan?
2.
So maknanya bilangan dia 2. Maknanya 2 mol. 2 mol aluminium ion. Awak jangan darabkan dengan charge tau. Awak jangan darab dengan charge tu.
Tak payah buat punya equation macam pecahkan dia punya ion tu betul.
Tak perlu.
Okay.
Tak perlu. So awak tengok je ada berapa ada nombor berapa sebelah elemen tu. So we have 2 mole of aluminium ion. So 1 mole is equals to Avogadro. So 2 mole is equal to Avogadro multiplied by 2. So number of oxide ion. So 1 mole of aluminium oxide is equivalent to how many mole of oxide ion?
3.
3. Okay, correct. So 3 mole of oxide ion. So mean 3 multiplied by Avogadro. Okay, so kalau awak dah faham yang basic konsep yang ni, awak dah faham macam mana kita ratio kan dia. So dah senang lah. Awak boleh jawab lah soalan dalam tutorial semua. Sebab chemistry senang je, calculation dia. Semua based on mole. Kalau awak keliru, when in doubt, just find the number of mole. Because from the number of mole, awak boleh cari mass, cari volume semua. Cari molarity semua. Sebab tu senang ni. Okay, so molar mass. Okay, molar mass. Okay, so by definition, molar mass is the mass of 1 mole of any substance. Okay, so the berat for 1 mole lah. And the unit for molar mass is gram per mole. Okay, so molar mass ni awak ambil je daripada periodic table. Okay, so later insyaAllah lepas ni saya akan upload basic relative atomic mass yang biasa digunakan dalam exam. So after this, any calculation kalau tak diberi dalam soalan, awak just guna table tu. Sebab kalau dalam exam nanti dia akan bagi table, dia akan either bagi dekat depan ataupun the mass will be given in the question. Okay. So one more of any substance lah. So let's say if I have water. Water. So in order to find the molar mass of water, you need to get molar mass of hydrogen. You need to multiply by 2. Sebab kita ada 2 depan ni. Plus molar mass of oxygen. Sorry, A, bukan M. Okay. So let's say kalau saya ada copper to sulfate pentahydrate. Dot ni menunjukkan apa dot? Plus or multiplication?
Plus.
Plus.
Plus. Dia menunjukkan tambah. Tapi kalau dalam mathematics, dot tu multiplication, darab. So awak kena bezakan sikit. Dia akan ada beza sikit. Kalau ni soalan macam ni pun agak famous juga sebenarnya dalam chemistry ni. Especially for chapter 1 dalam stoichiometry nanti. Dia agak famous juga. Okay, so the molar mass basically awak just tambah je lah mass yang dalam periodic table tu. So awak akan dapat lah. So example for H2O, for 1 mole of H2O, the mass is going to be 18 gram. So let's say if I have 2 mole of H2O. So berapa mass dia sekarang? Kalau 1 mole 18 gram, 2 mole
6.
36.
okay, so correct. 36 gram. Macam tu je. Okay. Boleh
Boleh.
Okay, next molar volume. Okay. So molar volume you're going to learn further in chapter 5. Okay, molar volume, because in chapter 5 we're going to focus on gas. Okay, so basically molar volume come from Avogadro. So Avogadro ni basically nama orang lah. So Avogadro, dia propose Avogadro's law. Okay, in that law it proposed that doesn't matter gas tu jenis apa, as long as the number of mole is 1 mole and we measure at the constant ataupun the same condition, dia akan occupy volume yang sama. Okay, so tak kisah dia gas apa, as long as dia 1 mole, volume dia mesti sama. So if we measure the gas at a standard temperature and pressure, so standard temperature and pressure which is 0 degrees Celsius and 1 atm, 1 mole of any gases will occupy a volume of 22.4 liter and it will contain Avogadro's number of gas molecule. So sometimes standard temperature and pressure ni dia short form kan jadi STP. Okay, at room condition, room condition 25 degree and 1 atm. So any gases that occupy a volume of 24 liter will contain Avogadro's number of gas molecule which is equal to 1 mole. Maknanya kalau awak measure 1 mole of any gases at room condition, volume dia mesti sama, 24 liter. Okay, volume mesti sama. Okay, so untuk ini awak kena tahu conversion lah. So milliliter to liter you need to divide it by 1000. Centimeter cube to decimeter cube you also need to divide it by 1000. So 1 liter is equal to 1 decimeter cube. Ini yang basic unit conversion that you need to know to calculate the molar volume. Okay, remember STP 22.4 liter, room condition 20 liter. Okay, so ni yang saya cakap tadi. Okay, it doesn't matter what type of gas yang awak ada, as long as the number of mole is equals to 1 and you measure at the same condition, dia mesti akan occupy volume yang sama. So let's say macam ni kita ada helium, nitrogen gas and oxygen gas. All these three gas have same number of mole and measure at the same condition, the same pressure and the same temperature lah. So awak tengok dia punya volume dia semua sama. Ni mana ni dekat STP lah 22.4. So if you measure at room temperature, then it's going to be 24 liter. Okay. Okay, boleh ni?
Boleh sir.
Boleh Okay. Kalau okay, kalau tak ada persoalan, okay. Yang nanti kejap lagi saya akan upload few exercise. Okay, exercise tu awak tak submit lah. Dekat exercise tu saya dah bagi final answer, so you boleh berlatih sebab untuk lesson kita pada hari esok, apa yang kita belajar hari ni kita akan gabungkan dalam satu calculation buat esok. Saya akan ajar macam mana awak nak take soalan yang calculation berdasarkan semua ni lah. Okay, concentration. Okay, concentration. So, saya rasa semua orang akan pakai perfume lah. Semua orang akan pakai perfume. Kalau awak tengok, every perfume they have their own label. Ada yang apa, beauty parfum, toilet, semua tu. Ada cologne, semua tu. Okay, the difference between those label is depend on the concentration of the fragrance. Maknanya ada berapa amount fragrance dalam alcohol yang kita gunakan to dissolve the perfume. Normally perfume memang kita akan guna alcohol lah sebagai kita punya solvent because alcohol has a very low boiling point. So maknanya kalau kita spray perfume tu dia punya droplet tu is very small, so dia akan disperse easily in the air lah. Compare kalau kita guna water. Sebab water kalau awak tengok, so macam normal alcohol dia punya boiling point dia dalam around 25, which is at room temperature lah, 25 or 30. Tapi kalau water, we know that the boiling point of water is 100 degrees Celsius. So if you use water as a solvent for your perfume, the droplet dia akan besar dan susah sikit nak merebak dan dia akan letak stain dekat baju awak. That's why lah kita akan normally alcohol kita guna dalam perfume. So untuk hari ini kita akan belajar the different way we can express concentration ataupun kepekatan lah of any substance. Okay, so concentration normally kita boleh guna term concentration for either gas or liquid ataupun solution. Tapi most common the most common kita gunakan concentration ni adalah untuk describe solution lah. Describe solution. Okay, dalam solution, solution must consist of two things. The first one, we need the solute, and the second one, we need the solvent. Okay, we need the solute and we need the solvent. Solute is the substance that you dissolve. Maknanya bahan yang kita akan larutkan. Solvent adalah bahan pelarut. So let's say kalau ada gelas, water, okay, ni ada sugar. Which one is the solute?
Sugar.
Sugar is the solute and water is the solvent. Okay, boleh? So sugar solute, water solvent. And water is we call it as a universal solvent. Sebab water ni dia boleh dissolve banyak benda lah. Okay, so nanti and solute ni tak semestinya solid. Solid awak ingat solute tak semestinya solid. Solute ni anything yang awak dissolve kan lah. Contohnya kalau awak nak bancuh air Ribena for example. Okay. So Ribena awak tak adalah solute. Dan kalau kita tahu Ribena yang kita beli dalam botol tu dalam bentuk liquid. Tapi kita masih panggil dia solute sebab kita akan dissolvekan dia. Itu beza. Ingat solute tak semestinya solid. Okay. So a solution must consist of solute and solvent, and the concentration of the solution is often expressed as quantity of solute. Quantity. So the quantity can be either number of mole, can be either mass, can be either volume. Quantity. So tak kisahlah, mole boleh, mass boleh, volume. Okay, dissolve in a given quantity of solvent. So for a given volume of a solvent, okay, so let's say this one I have glass A, this one glass B. Okay, both have the same volume of water. Okay, both have the same volume of water. Okay, in glass A saya masukkan 2 tablespoon of sugar. In glass B saya masukkan 12 tablespoon of sugar. Okay, which of the glasses contain the highest concentration of sugar? A or B? B lah. Sebab lagi banyak solute yang awak dissolve, then the more concentrated the solution is going to be. So that's why concentration is basically the ratio between the quantity of the solute dissolved in a given quantity of solvent. Okay, and we can express concentration by using different method. Okay, we can express using different method. Okay, we have 5. Okay, untuk silibus awak kita 5. Okay, molarity is the one that you already familiar. Molarity. So molarity is given by the capital M. The second one is molality. Molality is given by the small m. So molarity sometimes people call it as a molar. Molality, molal. You need to know the difference between molarity and molality. And then we have mole fraction, capital X, and percentage by mass. So WW means mass or weight. Doesn't matter whatever you want to call. V is a percentage by volume. These are the 5 different way for you to express concentration. Okay, so we go to the first one, which is the molarity. So molarity, molarity is expressed as the concentration of solution as the number of mole of solid per unit volume of solution. So molarity, mole per volume. So the number of mole of solute per volume of solution. Okay, so the unit for molarity can be either this one is a little bit mistake. So mole per liter or mole per decimeter cube or capital M. You can use either one lah, mole per liter or mole per decimeter cube or molar. So and the molarity is mole of solute over volume of solution. This is the formula. And the volume must always be in liter or decimeter cube. So kalau ada volume awak dalam ml, awak kena convert dia kepada liter. Kalau volume awak tu dalam centimeter cube, you need to convert itu decimeter cube. Okay, so far boleh follow setakat ini?
Boleh, sir.
Boleh,
Sir.
Okay. Ya, saya.
Kalau dia bagi, contohnya kalau dia bagi volume of solution tu dalam gram, tak ada selalu.
Dalam gram, okay, selalu kalau dia bagi dalam gram, setakat ni tak ada lagi soal tu, tapi kalau dia bagi dalam gram, mesti dia akan bagi density. So from there, you can find the volume of solution.
Alright, sir. Thank you.
Okay, welcome. Okay, so let's try this example together lah. Kita buat sama-sama. Okay, make sure our calculator Ada kertas, ada pen atau pensel dekat dengan awak supaya kita boleh buat sama-sama lah. Okay, sebab calculation ni kalau awak tak praktis, kalau awak baca je memang tak boleh buat lah. Sebab awak ingat chemistry ni bukan subjek yang menghafal. Unless semester 2 nanti lah, which is organic chemistry. So for the first semester, it's all about calculation. So you need to understand the concept for you to do the calculation lah. Okay, so the first question, okay, glycine has the simple structure of 20 amino acids. Okay, what is the molarity of a solution containing 0.715 mole of glycine in 495 ml of solution? So the question asks you to find the molarity of glycine. So normally kita akan buat macam ni lah. Kita akan tunjukkan molarity of glycine. Okay, we know that the molarity is equal to number of mole of solute. So the solute for this case siapa? Solute dia siapa? Itu soalan ni.
Glycine.
Okay, glycine kan. So number of glycine over volume of solution. So given in the question, the number of mole of glycine is 0.715 mole. Okay. Over, okay, give volume dalam ml. So you need to put to liter. So it's going to be 0.495 liter. So kalau awak kira, awak dapat berapa?
1.44
1.44.
mol
1.4?
kita negative 1.
44 mole per liter. Okay, 1.44 mole per liter. Okay, ni saya rasa semua orang dah tahu kot. Okay, unit for number of mole is mole. However, the spelling is quite different. The spelling is MOL, not MOL. Okay, so jangan pula awak tulis unit dia ni sebagai MOLE Okay, itu bukan unit. Unit dia adalah MOL. Okay, so question number 2. Calculate the molarity of solution made by dissolving 23.4 gram of sodium sulfate in enough water to form 125 ml of solution. Okay, so macam awak tahu, nak cari molarity, we need to have the number of mole and the volume. Okay, the volume is already given in the question, which is 125 ml or equivalent to 0.125 liter. Okay, tapi number of mole tak bagi. So number of mole nak dapat daripada mana?
23.4.
Okay, from the mass. So mass divided by the molar mass. Okay. So maknanya kalau kira, so mass of sodium sulfate, mole is equal to 23.4 divided by the molar mass. So the molar mass also is 142.1. So gram per mole. So you will get the mole lah. So awak akan dapat number of mole dia. So the number of mole is 0.165 mole. So if you calculate the molarity, okay, berapa dapat molarity? Molarity dia berapa? Molarity dia berapa? Ada yang dah kira?
1.31.
1.3.
Okay, 1.3, 1.31 or 1.3 lah. Okay, both are correct. Okay, normally if the question doesn't specify how many decimal places, awak buat two decimal place. Kalau soalan tak specify berapa decimal place, awak buat 2 decimal place lah. So if the question already specify how many decimal place or second figures, okay, then awak boleh ikut soalan tu. Okay, kalau tak, awak buat 2 lah, 2 atau 3. Okay, 4 tu terlalu banyak. 4 terlalu banyak decimal place. Okay, okay, yang ni. Okay, so kita tengok molarity of ion in a salt solution. Okay, reason is sebab, okay, solution, kalau awak ada garam, especially a soluble salt such as NaCl. So if you dissolve NaCl in water, so kalau awak dissolvekan dalam water, so the NaCl will dissociate to become Na plus NCl minus. This one is only applicable for a water soluble salt lah. Okay, so the easy example is NaCl. Okay, so the molarity can be determined by using the molarity of the salt. We're going to use mole concept. Okay, so if we do the mole concept for NaCl, so 1 mole NaCl equivalent to how many mole of sodium ion?
1 mole.
1 mole of sodium ion and equivalent to 1 mole of chloride ion. So let's say if I convert the mole into molar, so I have 1 molar of sodium chloride. So how many molar of sodium ion? Sebab kalau awak tengok ratio dia semua satu-satu. So how many molar of 1 molar, right? Still the same. So 1 molar sodium ion and chloride ion is also going to be 1 molar chloride ion. So if I double the molarity, so now the molarity is 2. So what happened to the molarity of the sodium ion?
2 molar.
2 molar. Okay. 2 molar of sodium ion, 2 molar of chloride ion. So senang je. That's why recap balik pasal mole concept. Sebab dia berkait. Dia akan memudahkan kerja awak. Okay, so example tu. What is the molar concentration of each of the ion present in 0.025 molar aqueous solution of calcium nitrate? Okay, calcium nitrate. What is the formula of calcium nitrate?
CaNO3.
CaNO3 je.
Ca bracket NO3 bracket 2.
Okay, correct. CaNO3 tu. Ingat, okay, sebab apa kita ada bracket semua tu? Okay, Ca, the ion of Ca is Ca2 plus. Nitrate is -1. So if both ion combine become salt, so kita akan bawa charge dia ke opposite side. So Ca will gain the -1 charge. Okay, zinc NO3 is a polyatomic ion. That's why kita kena bracketkan dia. That's why we going to become 2. Okay, we have 0.025 lah. Tapi kita kena start dengan standard. Standard kita adalah 1 mole. So 1 mole of CaNO3 2 is equivalent to how many mole of calcium ion?
1.
1. So correct. So 1 mole of calcium ion and how many mole of nitrate ion?
2.
2.
2 mole of nitrate ion. So given in the equation, the molarity is 0.025. So molar of calcium nitrate. So molarity of calcium ion?
0.025.
5. Okay. Calcium ion and the molarity of nitrate is going to be double. Kan sebab awak tengok ratio is 1 to 2. So the ratio is 1 to 2. So it's going to be double. So double 0.025 is 0.05
0.05.
molar nitrate ion. Okay, boleh tak ni? Semua okay. Boleh follow lagi setakat ni. Ni dapat
Okay, sir.
risau saya dah pukul 3 lebih
Boleh
ni.
sir.
Boleh Okay. Tadi kita dah belajar basic pasal concentration or molarity, dilution. Normally dalam lab, anything yang kita beli tu, semua dia bagi concentration is very high. So for example, kalau saya ada hydrochloric acid. Hydrochloric acid kalau awak beli daripada chemical factory, dia akan bagi dalam bentuk concentrated which is around 25 molar, 30 molar, dia bagi dalam bentuk powder. So from that concentrated solution, kita kalau dekat matrix ni eksperimen tak pernah lah lebih yang 5 molar. So selalu kita guna 0.02, 0.05 molar. So kita kena cairkan dia. So kita kena dilutekan dia. So you need to know to perform calculation. Calculation pasal dilution ni you going to apply for experiment 2. Because in experiment tu we going to do titration. Titration saya rasa dah pernah try kan waktu sekolah menengah. Titration. Sempat buat titration?
But
Sempat.
Sempat kan? Ya. Awak guna burette, phenolphthalein and all that. Okay. So kita akan apply calculation dilution and molarity ni dalam eksperimen tu nanti. Okay. So dilution is basically awak nak cairkan dia. Okay. And kalau the simplest way to dilute any substance is by adding solvent. By adding solvent. So contohnya, so for example, if I have a cup of tea life, boba. Okay. So let's say this one ada 10 tablespoon of sugar. Contoh je, saya tak tahu berapa konten dia. Okay, contoh kalau awak rasa dalam diri awak hari tu macam nak diet ke, nak rasa macam sihat, awak transfer ni dekat satu jug yang besar, awak tambah je air. Amount sugar dalam tu berubah ke tak? Amount sugar tu?
tak.
Tak berubah kan? Yang berubah hanyalah apa?
Concentration.
Concentration berubah and also the volume. The amount of the substance is remain the same. So that's why lah kalau beli benda manis macam mana pun, awak tambahlah berapa banyak air, the amount of sugar in that is still the same. Tapi beza dia adalah amount of solvent ataupun amount of solution yang awak yang consume. Itu saja. Okay. So for dilution, kita maintainkan number of mole dia. Okay. So reason kita kena tahu benda ni sebab kita normally dilution ada two different cases. Okay, for dilution ada two different cases. Okay, so the first one okay, macam yang tea life tadi. Tapi ni kita guna contoh chemical lah. Tak guna contoh tea life lah. Okay. So, ada beaker. Okay, saya ada 4 molar 200 ml of HCl. Okay, 200 ml of HCl. And then saya tambah 500 ml of water. Okay, for this case, the number of mole remain the same, tapi solvent dia yang berubah. Okay, solvent yang berubah. Okay, so we know that from the molarity, the formula for molarity, so molarity is equal to mole per volume. So now we know that the mole is the same. So mole is the constant. So manakala mole constant, maknanya mole is equal to molarity multiplied by volume with the mole as the subject. Okay, for this case, we know that the number of mole or the amount of substance before and after the solution is remain the same. So the number of mole initial is equal to number of mole of the final. And from this formula, we know that the mole is equal to molarity multiplied by volume. So we can expand this equation to become molarity initial multiplied by volume initial is equal to molarity final multiplied by volume final. Or sometimes you can use M1V1 is equal to M2V2 pun boleh juga. Tak kisah, as long as you understand how you get the equation. Okay, so for this case, molarity before and the number of mole before and after solution. That's why lah kita boleh guna formula ni. Okay, so contohnya untuk ini, the molarity before dia apa? Molarity before dia. Formula kan? So for volume initial is 200. Okay, molarity final we going to calculate. Okay, volume final dia berapa? Volume final dia?
700.
700, correct. Bukan 500 tau. Sebab asal dia initial kita dah ada 200. So tambah lagi 500. Our final is 700. Bukan 500. Yes, saya.
The volume should be in milliliter or liter.
Okay, for this case, it doesn't matter because the unit will be cancelled out. So kalau saya convert jadi 4 molar multiplied by 200 ml equals to molarity final multiplied by 700 ml. So molarity final is equal to 4 molar multiplied by 200 ml over 700 ml. So we cancel out the unit. So it doesn't matter. Tapi kalau
Okay.
nak save, as a good practice, convert to become liter. As a good practice.
Okay, sir. Thank you.
Okay, welcome. Okay, so example 3. Calculate the final molarity when 200 ml of water was added to a beaker containing 300 ml of formula HCl. Okay, so kalau macam ni, kita hanya solution je lah berubah. Volume of solution. So we can use molarity initial, volume initial equals to molarity final, volume final. So molarity final is equal to 4 molar multiplied by 300 ml over 500 ml. So boleh cancel out unit. So molarity final dia awak dapat apa? Molarity final
4.
2.4 and the unit is unit dia apa?
Capital M.
Okay, capital M, molar lah. Okay, capital M. Don't forget the unit. It doesn't matter kalau awak dapat value betul pun, without you dia akan terus automatic awak akan hilang markah. Okay, case number 2. Okay, so case number 2, if you have two solution. Okay, so this one is solution A. This one, for example, is beaker B. So both contain HCl. However, this one contain 1 molar HCl. This one contain 2 molar HCl. Okay, this one have 200 ml. This one have 300 ml. Okay, number of mole dia akan sama ke tak kalau awak mixkan dua-dua solution ni? Number of mole dia. Tak kan? Sebab tak, sebab number of mole dalam beaker A lain. Sebab molarity dia berbeza dengan volume berbeza. Dekat beaker B, the mole is different. Okay, so for this case, so the molarity final dia adalah awak kena find the mole of from beaker A tambah mole from beaker B over volume A tambah volume B. So it's still the same mole per volume. However, awak tambahkanlah dua-dua mole tu. Okay, macam mana nak cari number of mole untuk beaker A ni, macam mana nak cari number of mole dia?
MV over 1000.
Okay, MV over 1000. Okay, the reason kita divided by 1000 because we want to convert the milliliter to liter. Tapi kalau awak dah convert awal-awal, awak tak perlu over 1000 kan lah. So awak boleh guna ni. So awak akan dapat mole A. Awak guna formula yang sama, awak akan dapat mole B. Okay, volume A lah. Volume A okay, is 0.2 liter plus volume B is 0.3 liter. Okay, okay tak setakat ni?
Okay, sir.
Okay, okay. Kalau abang tanya je, kalau malu nak cakap ke, just type dekat chat tu. Okay. Ni sama je macam tadi. Sama je dengan case tu. So nanti awak boleh try lah. This one ada dalam notes. Ni the same question dalam macam dalam notes. Okay. Okay, just now we learn about molarity. Okay, molarity is mole of solute over volume of solution. Okay, and then we have molality. Okay, molal. The molality, okay, is the mole of solute over mass of solvent. Bukan mass of solution, mass of solvent. Itu beza. Sebab tu that's why awal-awal tadi saya terangkan what is the difference between solute and also what is the difference between solvent. Solute and solvent is different thing. So for molality is mole of solute over mole mass of solvent. And the mass of solvent must be in kilogram. Must be in kilogram. So the unit for molality can be either mole per kilogram or small m or molal. Dia mana-mana. Unit dia boleh mole per kilogram, small m or molal. So for example, okay, calculate the molality of sulfuric acid solution containing 24.4 grams sulfuric acid in 198 gram of water. Okay. So first apa kita kena buat? Ada berapa suggestion? Apa kita kena buat?
Cari mol
Cari number
Mol
of
siapa?
mole.
sulfuric
Sulfuric acid.
Sulfuric acid. Because sulfuric acid is the solute and water is the solvent. So the mole of sulfuric acid, okay, mole of sulfuric acid is equal to 24.4 gram divided by molar mass. Molar mass is given in the question. So 98.0 gram per mole. So if you calculate, awak akan dapat 0.249 mole. Okay, now we already obtained the mole of the solute and we can find the molality of the acid. So molality equal to mole of solute over mass of solvent. So the mass of solvent must be in kilogram. So from gram to kilogram, you need to divide it by 1000. So 0.198 kilogram. So berapa dapat molality?
One 1.258.
Okay, 1.258. And the unit is can be the mole per kilogram or small m or molar. So, so basically you need to know how to identify which one is the solvent, which one is the solute and which one is the solution. Itu je. And then the rest awak boleh ni lah. Okay. The next one, okay, another method to express concentration is a mole fraction. A mole fraction is given capital X. Okay, mole fraction is normally used in gas. Kita boleh juga guna dalam solution, tapi the most common uses of mole fraction is in gas. Because contohnya macam the air that we inhale right now is a mixture of different gas. So each gas have their own quantity ataupun ada berapa bilangan dia. And kita boleh gunakan mole fraction untuk expresskan concentration of different gas tu dalam campuran tu. Okay, so mole fraction is basically the ratio. So kalau ratio maknanya dia adalah bahagilah. Ratio between the number of mole of one component to the total number of mole of all component. Okay, basically kalau saya ada beaker. This beaker is a mixture of solution A, solution B, solution C. And each solution have their own number of mole. Okay, if I want to find the mole fraction of A, so what it mean by the formula mole of component, which is mole of A. Mole of A divided by total mole of all component. Since we have 3 components, so we need to divide it by mole A plus mole B plus mole T. Okay ni.
Okay, sir.
Okay. Same goes if you want to find the mole fraction of B. So we need number of mole of B over mole A plus mole B plus mole C. And mole fraction for C is mole C over mole A plus mole B plus mole C. And the sum of all the mole fraction, so XA plus XB plus XC must equals to 1. The sum of all mole fraction must equals to 1. Mesti wajib sama dengan 1. Okay. So example 6. Okay, sample of ethanol contain 200 gram of ethanol and 150 gram of water. So calculate the mole fraction of ethanol and water in solution. Okay, so first kita kena convert the mass to number of mole. Kita kena convert dulu. Okay, so the mole of ethanol is equal to 200 gram. Okay, so the molar mass of ethanol is 46 gram per mole. So awak akan dapat 4.35 mole. Okay, and the mole for water, so given that the mass of water 150 gram and the molar mass is 18 gram per mole. So the mole of water in this case is 8.33 mole. Okay, so in order to find the mole fraction of ethanol, okay, the mole fraction of ethanol, okay, we need to take the mole of ethanol, which is 4.35 mole over total mole of all component. So 4.35 plus 8.33 mole. Okay, mole fraction ada unit tak mole fraction? Ada unit tak?
No.
No, because both the unit can be cancelled out. Okay, so if you calculate, okay, what is the mole fraction for ethanol?
0.34.
0.34. So for water pun awak buat benda sama juga. Cuma for water, yang atas ni awak tukarkan kepada 8.33 mole. So kalau awak kira mole fraction water, awak dapat berapa? Mole fraction for water. Kira dapat apa?
0.66.
So the mole fraction for water is 0.66. Okay. Itu je. So basically kalau calculation ni sebenarnya tak ada apa-apa sangat. Cuma awak kena fahamkan betul-betul question tu. Dia tanya apa yang dia nak dan what is the information given in the question. Okay, itu je. Okay, ada lagi dua je lagi. Berkenaan concentration. Tapi both is similar. Okay. We have percentage by mass and percentage by volume. Okay. Percentage by mass is the mass of solute per mass of the solution. Okay, and the mass of solution is equal to mass solute plus mass solvent. So awak kena bezakan lah. So mass solution sama dengan mass solute tambah mass solvent. Okay, so for example kalau satu botol chemical, so dia tulis 90% by mass of HCl. So let's say the volume of the solution in the bottle ataupun mass dia adalah 100 gram. So kalau mass solution 100 gram and the solution contain 90% mass of HCl. Okay, berapa mass HCl dalam ni? Berapa mass HCl, berapa mass water? So berapa mass HCl ni, mass dia?
90 gram.
Okay, correct. 90 gram. Mass water?
10 gram.
10 gram. Okay. So kalau saya convertkan mass ni kepada 200 gram. So the new mass of HCl is? Dia akan jadi apa? Kalau saya doublekan
180
berat dia. So 180 gram and the mass of water is going to be 20 gram. So this is basically percentage by mass. Ini adalah percentage by mass. So okay, boleh dengan konsep percentage by mass ni. Okay. Okay, example 7. Okay, a sample of 0.892 gram of potassium chloride is dissolved in 54.362 gram of water. Okay, so what is the percentage by mass of KCl? Percentage by mass of KCl is equal to mass solute. So which one is the solute? KCl or water?
KCl.
KCl. And the mass of KCl is 0.892 gram. So over mass of solution. Okay, this one mass solution ke?
Bukan.
Bukan. Ini adalah mass solute. So the mass of solution, mass solute plus mass solvent. So 892 gram plus 54.362 gram multiplied by 100. So if you calculate what is the percentage by mass of KCl?
1.61%.
Okay, 1.61%. Okay, percentage by volume is the same as the percentage by mass. The difference is yang tadi awak measure guna mass, now you measure by using volume. So sorry, this one is V over V. Itu je, and sorry ml or centimeter cube lah. Dia sama je. So for example, if in bottle, okay, kalau saya ada bottle yang sama, so 90% of HNO3. So kalau saya ada 100 ml, so what is the volume of HNO3? What is the volume of water? Cakap 90%. Volume HNO3 berapa volume dia?
90 ml.
90 ml and volume of water is 10 ml. So dia yes, correct, 10 ml. Dia sama je dengan percentage by mass. Okay, boleh tak ni?
Boleh.
Boleh
Boleh.
Alright. So, okay. That's all for today. So, in the next lesson, which is tomorrow, we're going to learn how to answer tutorial question 11, 12 and 13. Okay, because in this particular question, dia akan combine semua pasal concentration ni dalam satu soalan. Dan awak kena buat few assumption. Starting dekat matrix, awak soalan chemistry ada certain part yang awak kena assume. Awak kena buat assumption sendiri. Tapi awak bukan boleh main buat je assumption dia. Dia ada teknik dia. So for tomorrow, we're going to discuss how to answer question 11, 12 and 13. Okay, after this, I will upload in group telegram few questions just for you to practice the different expression concentration. So awak tak perlu submit soalan tu, awak just jawab and I already provide the final answer on the question. So awak boleh check terus dengan final answer tu. Okay, sebab awak kena mahirkan yang basic dulu baru yang kita boleh go kepada yang complicated sikit. Sebab tu agak complicated sikit lah. Okay, so if you don't have any further question, okay, thank you everyone for joining the class for today. So you boleh rehat, pergi dah mana-mana. Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.